A quadratic equation is a polynomial that simplifies to this form. Now, a1 and a0, these are constants. These can be equal to 0, but a2 cannot be equal to 0. If it were, this would go away, this whole term would cancel, and you just get a1x plus a0 equals 0, and that's linear. That's a linear equation. We want strictly nonlinear. And with this quadratic equation, the linear equation solution methods will not work. So we're going to have to look at other types of methods. Now, if the variable is underneath of a square, the process ends up being fairly simple. We're going to first start off using the linear equation method where we're going to solve for the variable. But to get the variable by itself, we have to do a little bit more stuff to it. So first off, I'm going to open up any parentheses. We can distribute this -2. It's going to be minus 10 minus 42 equals 46 minus 4x squared. And we need to get the variables to one side. I'm going to add 4x squared so that it becomes positive. And I can combine these two like terms into -52. Okay, I should write that down here. This is going to be 2x squared minus 52 equals 46. Now I can add the 52 over. 2x squared equals 98. Divide by 2. X squared equals 49. And now I need to take the square root. Linear equation, this would be the end result, but here we have a square in there and we want just x. So we have to take a square root. And the key thing to note is that whenever you take a square root, you must add a plus or minus in front of it. Whenever you take a square root, a fourth root, a sixth root, an eighth root, any even powered root, add in a plus or minus. That's because x can equal plus or minus 7 in this case. If you go back up here and you test positive or -7, no matter which one you plug in, this square is going to end up being 49, and this square will be 49. That's because the positive 7 squared is positive 7 times positive 7, which is positive 49. -7 squared, negative times negative is positive. 7 times 7 is 49. So you get the same answer. And so you actually have two solutions here, positive and minus, plus and minus 7. Okay, for the next one, same process. The x is underneath the square. In this case, it's inside parentheses, but that's fine. I'm going to subtract the 48 to both sides. That's going to give me x minus 10 squared equals -48. And now I can take the square root. Again, whenever I take a square root, add in a plus or minus. Now in this case, we're going to get a complex number, right? I'm going to take the negative out as an I. And I can simplify the statement down. So that's going to give me, there is a 4 in there. There's actually a 16 in there, I believe. 16 times 3. 32, yep, 48. And so I can take out a 16. Because the square root of 16 is 4. And now I can add 10. And that gives me my two solutions, which happen to be complex in this case. Okay, let's graph these things. I want to show this first one graphed. And you can see here, when it equals 0, if I subtract 46 over to this side, to the left side, add 4x squared to the left side, then I get this equation. And then this equation equal to 0 is the same thing as the x-intercepts. That happens at 7 and -7, which is what I found. Of course, for the next one, if I graph that and zoom out, you can see that this quadratic, which is going to look like a parabola like this will never go back down. It always goes upward, never falls, and never crosses the x-axis. This equation is equal to 0 when it crosses the x-axis, but it never does because we have a complex numbers. And so that shows up on the graph as it never crossing the x-axis. So to solve these equations, you actually have to do the algebraic method. You cannot solve it using the graph. Okay, now for general equations where you may not have the x only underneath the square, as you can see here. In this one, we have x squared and x. What we want to do is get it into this form and then try and factor it. So let's go ahead and do that. I'm going to subtract 20x, add 80. That's going to give me 5x squared minus 40x plus 80. And now I can divide everything by 5. That's going to give me x squared minus 8x plus 16, I believe. And I can factor this thing down, right? A times c is 1 times 16, negative 8. Two numbers that multiply to give 16, add to give negative 8. Negative 4, negative 4. Since a is 1, I can immediately factor this down using x minus 4, x minus 4. And this gives me, this solution is going to be x minus 4 equals 0. And this one says x minus 4 equals 0. Of course, both of them give me the same exact answer. X equals positive 4, x equals positive 4. There's only one solution in this case. It's repeated twice, but there's only one solution. Now for the next one, I'm going to do the same process. I'm going to add 4x squared, add 10x, and subtract 6. 24x squared plus 13x minus 7. And I can try the AC method on this one. A times c is 24 times negative 7. It's going to give us, grab my calculator here, negative 168. B is just 13. And so now I need two numbers that multiply to give 168, negative 168, and add to give 13. So to do that, I'm going to look at a table. Obviously 1 times 168. 2 times 84, that's still going to be way too far apart. I don't think 3 can go into there. Oh, it can. 3 times 56. 4 can. 42. Still too far apart. We went only 13 from this. So let's try... 5 can't. Let's try 6. 6 is closer, but not quite. I'm going to try 8. 8 and negative 21. If I add these up, I'm going to get negative 13, I believe. Yep. I want positive 13, so all I have to do is flip the signs. And that will give me exactly what I want. Negative 8 times 21 is negative 168. Let me just double check that. Yep. And then they add to give positive 13. So we have 24x squared minus 8x plus 21x minus 7. Again, I just broke up the 13 into these two numbers and left these two the same. Now I can look at the first two. I can take out an 8x from the first two. Give me 3x minus 1. And out of the next two, I can take out a positive 7, since this is positive, plus 7. Give me 3x minus 1. And that gives me 3x. And on the outside, we have 8x plus 7. So once again, the only way that these two things, the only solutions that this can have is if each one of these things are equal to 0. So 3x minus 1 equals 0. 8x plus 7 equals 0. That's the only way you can have 0 from this. So we're going to add 1 to both sides, subtract 7, divide by 3. Here we get 8x equals -7, divide by 8. And we get x equal to 1/3 and x equal to -7/8. All right, let's graph these and see what the solutions are. So we should expect one solution, x equal to 4, and these two solutions here. Once again, I moved it all over to one side. And graphing this one, the only solution it is right there at 4. It does not cross the x-axis. It just goes right there. It touches it and it turns back around, never crossing it. So there's only one solution. That's why it can only have one solution. However, whenever you see this type of thing, you'd expect there to be 4 twice, or whatever number it is twice. Okay, for the next one, we have this quadratic, quite sharp, like that. And looking at the solutions, we get, that's the same thing as 1/3, which is what we found. And this, if you plug it into a calculator, -7/8, yeah, is -0.875. So that is also true. Okay, the quadratic formula will always work to simplify a quadratic equation. And it's a great fallback because if nothing else does, this one will always work. You have to have ax squared plus bx plus c equals 0, which is the standard form that we would normally have it in. And this is the quadratic formula. You just plug a, b, and c into there and simplify. Now, inside this thing, we have the discriminant. The discriminant is the part underneath of the square root. It specifies the types of solutions, because underneath the square root, right, is the only place we can get a complex number. If you have a negative underneath there, you get a complex. If it's positive, that means it must be real, because that's the only way it could become complex. So if b squared minus 4ac, that's just this portion underneath the square root. If that's greater than 0, that means we have two real solutions, because the two solutions come from this plus or minus. And if the square root, it's the square root of a positive number, we have plus or minus some positive number, which gives you two distinct things. If instead we have 0 underneath the square root, then plus or minus the square root of 0 is just 0. So this whole thing cancels down into negative b over 2a. And that's a single real solution. That's the reason why that gave us only one, like in that previous example where we had only one solution, x equal to 4. That's because this is the case here. And of course, if this discriminant part is less than 0, the square root of a negative number is complex. So we have two complex solutions. The plus or minus is going to give us the two of them. Okay, let's actually try this out in 3 different quadratic equations. Each one of these I believe we've seen before. For this one, the discriminant, we have a, b, and c. So the discriminant, b squared minus 4 times a times c is going to be, let's go ahead and plug this in a calculator, 13 squared is 169, then plus 4 times 24 times 7 gives us 841. That means that this is greater than 0, so we have two real solutions. And we can check that. This was the case right here, right? And we solved for two real solutions, x equal to 1/3 and x equal to -7/8. So the discriminant just tells us that we can expect two real solutions. It's pretty easy to find as well, so that's why it's a handy tool to know what you're looking for. This one gave us x equal to 4, So we expect this to have one repeated real solution. A is 1, B is -8, and C is +16. So we're going to have B squared minus 4 times A times C. It's going to give us 64. This is -64, which gives us 0. So it has one real solution, which is in fact what we found. Okay, finally, this one gave us two complex solutions. We solved this by subtracting the -48 and then taking the square root. That's what gave us two complex. So we know it has two complex. Let's go ahead and test the discriminant. Now in this case, we actually have an issue because it's not in this form. We want it in this form. We can do that by expanding this. So give us x squared minus 20x minus or plus 100 plus 48. X squared minus 20x plus 148. Okay, A is 1, B is -20, C is 148. So we have B squared minus 4 times A times C. Doing that gives us, it's going to be 400 minus 4 times 148, -192, which gave us two complex solutions. So that's just the confirmation that the discriminant does actually do what it tells us. And it's a quick way of finding out what kind of solutions you want. Now, in practice, just doing the quadratic formula will get you the answers. It's not too much more work to just find the quadratic formula, but you really want to do the quadratic formula as a last case scenario. Sometimes this thing can be a little more involved, especially if you have complex numbers, whereas factoring can be quite simple and quite fast, but it's kind of up to you what you want to do. All right, this one here, I'm going to try and factor it first. I can't do the moving it over and taking the square root because we have an x here in addition to x squared. So let's go ahead and try out the factoring method. So A times C on top is 8, 2 times 5 is 10. B is just +2. Two numbers that multiply to give 10, add to give 2, and nothing does that. So we have to use the quadratic formula. Okay. X equals, this is A, B, and C, -b, -2, plus or minus the square root of b squared, 2 squared, minus 4 times A times C, all over 2 times A, or 2 times 2 is A, so 2 times 2. Just go back to the quadratic formula and plug in A, B, and C into here. Okay, simplifying the statement down, we're going to get -2 plus or minus, it's going to be 4 minus 40. It's going to give us -36. I can take out the negative as an I, and then the square root of 36 is 6. And I can reduce everything by 2. That's going to give me -1 plus or minus 3i over 2. Of course, we'd like to have this in the standard a plus bi form. So I can do that by just distributing the denominator. So these are our complex numbers. -1/2 is a, plus or minus bi. B is just 3/2. Now A and B are of course different from this. A and B, just don't confuse those two things. This is the a plus bi form. This here is ABC is the quadratic equation. It's just different uses of A and B for different concepts that we're working with. Regardless, we have two complex solutions. Okay, for the next one, let's go ahead and get this in the proper form. Ax squared plus bx plus c. And see what we can do from there. So I'm going to add x squared, subtract 12x. I'm going to write it from x squared first, and the 12x, and the 9. So 4x squared minus 12x plus 9 equals 0. Let's try factoring this. A times c is 9 times 4 is 36. B is negative 12. Two numbers that add to give 36, multiply to give 36, add to give negative 12. I was thinking 8 times 4, but that's 32. It has to be 9 times 4 is 36. 2 and 18. 3 and 13. Sorry, not 3 times 13. 3 times 12. Of course, that one doesn't work because we need to get 12. And then 4 times 9. That gives you 13 when you add them together. Yeah, I don't think anything works. 6 times 6. And that'd be 9 times 4. So nothing works here. Let's go ahead and try the quadratic formula. All right, so x equals negative b. B is negative 12, so we're going to get positive 12, plus or minus b squared, negative 12 squared, minus 4 times a, which is 4, and c, which is 9. All over 2 times a is 4. Okay, we're going to get 12 plus or minus 144 minus 4 times 4 times 9 is 144 as well. All over 8. 12 plus or minus, this is just 0. The square root of 0 is 0. So we get 12 over 8, which is 3 over 2. We get one real solution that's actually repeated. Okay, for this last one, we have absolute value. And remember, when we are solving for absolute value, the way we do it, we get the absolute value by itself, like we have here. Then we're going to break it up into two equations. The first one is the positive version. And the next one is the negative version. So we're just going to make negative 26. Now we can solve each. And this one has the variable by itself underneath of this square. So I get z squared equals 36 and z squared equals negative 16. And here I can take a square root. Always remember to add a plus or minus. That gives me plus or minus 6. And here I can take a square root. That gives me, I can take the negative out as an I. The square root of 16 is 4. I forgot to add a plus or minus. You see we get 4 solutions in total. That's because an absolute value tends to have 2 solutions, and then a quadratic tends to have 2 solutions. So if the absolute value breaks into 2 equations, each one being quadratic, there should be 2 times 2, 4 solutions in total. All right, let's graph these and see if we can get the same solution. So for the first one, this one's complex. This should not have any x-intercepts, so we should not see any solution from this one. This one, we should see the quadratic just touching the x-coordinate at 3/2. And finally, this one, we should be able to see these two, but these two we will not. So for the first one, you can see it's a quadratic that does not cross the x-axis. So these are complex solutions, which is what we got. This one, you can see it does cross the x-axis. Crosses it right at 1.5, or in other words, 3/2. And this one, you can see it's a strange quadratic. That's because of the absolute value. And we have solutions at negative 6 and 6. And those are the only 2 solutions we find, because the other 2 are going to be complex, and those will not show up on the Cartesian coordinate system. All right, give it a try in number 1.